Good morning, afternoon, evening to everyone. Today is January 25th, 2011, and we're going to be continuing with day 3 of gravity. But in order to continue, I think it would be best if we understand a principle that we're going to be using throughout the whole forces, motion, and energy chapters in the textbook. So let's go ahead and start with something I like to call units of measurement. Okay? Now, I don't know if anybody's ever heard of the term SI unit, but let me go over that briefly. The term stands for System International, or International System. We abbreviate it thus SI. These are the common units that we use in standard scientific applications, and we use them to quantify things such as distance, length, volume, and I have passed out a handout to the class called Units of Measurement. It looks something like this. And it also has another activity on the back which we're going to be completing subsequently. But for everyone to understand this concept of measuring forces, measuring energies, we need to be able to understand what units we actually talk about whenever we do these type of procedures in the class. All right, so number one, we want to know the quantity, all right? And number one asks us for distance and length. So match the quantities below to their SI units, the directions say. So let's go over these together. When you think of distance and length, what's one unit that you would use to measure distance or length? Okay. After you've written your answer down, I will write it up here. In fact, let me just read them, and then after you had a chance to write them down, we'll go ahead and continue. So number 2 asks for time. Think about something that would be used to measure time. Number 3 is speed. Number 4 is mass. Number 5 is volume. 6 is area. 7 is density. 8 is force. 9 is electric charge. And 10 is energy in general. Okay, so out of all those choices up on the word bank, A through J, we might say that the best choice for distance and length would be meters, right? Abbreviated M. All right, so that is choice B. So for time, time is pretty standard. We all know that the unit for time would be seconds, right? How about speed? If you said meters per second, you'd be correct. Have you ever weighed mass? Most of us think that we would weigh it in pounds or ounces, but those are actually the US forms of measurement. The more standard SI unit of measurement is actually kilograms. How about volume? Now, when we think of something contained in a container, let me, for example, draw a cube. As terrible as that drawing is. So let's make this cube here. Let's say we have a cube that's 1 meter high by 1 meter wide and let's say by 1 meter deep. All right. So we have 1 meter 1 meter, and 1 meter. So, very simply put, when we're measuring volume of a cube, we have 3 meters. So, that means we would have cubic meters, right? So the best choice for 5 for volume would be m to the third, or cubic meters. How about area? This one can be tricky. Some people might actually choose several choices for this. But the easiest one for area, let's say you have a floor. This is a rug. Let's just call it an area rug. Oh, well, there we go, pretty much. I think we can do it now, right? When we think of an area rug. Well, think about it. You've all seen carpets in places, right? Let's say we have a carpet that measures 3 meters this way. Okay? This is 3 meters long. Okay? And let's say that the carpet is 2 meters long, high. Would it be correct to say that we have the same dimensions up here going across and the same dimensions going up and down, or north and south, however you have the rug positioned? Yeah. So we have 2 different sides we're quantifying, right? So area then would be square meters. Okay. Now how about density? This one actually is pretty hard. This is one you probably won't be using throughout the unit, but this one would be kilograms per cubic meter. Because what we're doing is, let's go back to this cube, okay? Let's say we drop a marble into a huge marble into this cube, and let's now say that the cube is filled with some type of liquid, water. All right. Let's say the cube is a styrofoam cube and it floats on the water, or the styrofoam marble floats on the water. Sorry, inside the cube, and we want to know how much it weighs in the actual cube without using a scale to quantify, okay? We have a certain volume of liquid inside the cube that has a certain volume and a certain weight. If we were to drop this marble into the actual tank, we would get a representation of its mass by the volume that it displaces, because this marble that we put in here is actually going to rise the liquid. That's beyond the scope of what we're doing right now, but we will potentially get back to that at another time. Alright, force. This will be a big one going forward in other chapters in the book. Famous guy. It's a hint. Saw the apple fall from the tree. Remember that one? The Newton. Electric charge. Now, in America, we might have heard of the watt. We might have heard of the ampere, or amp. But chances are, most of us by 7th grade have never heard of something called the joule. And it's written like this, J-O-U-L-E. Joule. And finally, energy. Well, there's only one left, and that would be the calorie, C. Calorie is definitely beyond the scope of anything we're doing at this point, but it is important that you understand what we'll be measuring these things in. So my suggestion is save this sheet and do not lose it because it will be invaluable to you throughout the duration of the course. Okay, so now that we have an idea of what we use these units for, I'd like you to do a little converting units activity. This is similar to what some of us did probably the second week of school when Ms. Dickerson did a SI unit lab. But the directions say, converting from one set of units to another involves multiplying by a conversion factor, that is, a ratio of units that is equal to 1. Use the tables to find conversion factors to make the conversion specified below. So let's do number 1 together, and I'll let you continue with the activity. We're just going to write in the middle of the board here. It says 745 meters equals blank meters. Okay, what do we think of whenever we are converting from mm to m? Do we remember that? Remember that little acronym that you got in either Mr. Gilda's or Mrs. Monego's class? Karen has damaged many little gifts during Christmas Day. Use that pseudonym again to do a conversion, but remember that milli, in this case, equals 1,000th of 1 actual unit, right? So 745 millimeters is actually 745 thousandths of a meter, right? So it involves some very, very complicated division, but the really easy take-home lesson here is you have 745, all right? You're just going to move the decimal point over 3 to the left, okay? Doing that, you get 0.745 meters. That's it. It's a function of moving 3 to the left, but if this helps you remember it more easily, then do that. All right? Come to me with any questions that you have about the converting units, and I will help you accordingly.